Hi guys, in this lecture and the following we are going to talk a bit about sockets. A socket is the entity that actually takes care of the basic low-level communication between a client and a server. Like for example, when you sit at your PC and open a web page on a web server. Your PC is the client, and what it does is it opens a socket to connect to the socket already opened on the web server. You can say that sockets are the endpoints of the communication path between a client and a server. Now, a socket address, as Wikipedia clearly defines it, is actually the combination of an IP address and a port number. Based on this address, Internet sockets deliver incoming data packets to the appropriate application, process, or thread. Now let's see these IP port combinations both in Windows and Linux. In Windows, you should open a command prompt window and just type in the following command. So let's do a cmd netstat -n, where n right here in the command stands for numerical output. The output is a list of active connections where the first column represents the protocol of each open socket. You can see TCP, for example, in the first column. Next, we have the local socket. So the socket currently open on the client PC. Notice the IP address and port are separated by a colon right here. Let me mark one pair to see it better. This is the local IP address, and this is the port that the computer uses to connect to the server. This is normally a pseudo-randomly generated number, and it is very useful when the computer receives a reply from the server. This port number helps the computer to redirect the server's reply to the local process that asked for that reply. Okay, in the next column you have the remote socket made of the remote IP address and also the port, the remote port. This is the one right here. These are used by the server to listen for requests. In this case, the port corresponds to a particular service on the server. Like, let's say, maybe you have port 80, like I do right here, for HTTP operations. Finally, the last column shows the state of the communication between those sockets, so you can see established. Okay, now let's look at sockets in Linux. Let me open my virtual machine. In Linux, you can use the following commands, so netstat -net to see the open sockets, where N stands for numerical output, A stands for show all, and T stands for TCP. In this output, we can see the protocol as in Windows, so TCP or TCP6 for IPv6. Then the local address and port pair. You can see the loopback address and the port associated with it. You can also see the foreign address and port pair, and finally the state of the connection, which is either listen or established in my case. In Python, we have the module called socket for creating and handling sockets. In this lecture, we are going to create a server socket, and in the next lecture, we are going to build a client socket. At the end, we want these two sockets to communicate. Now we are in the working directory. Let's create a new file and name it socket server.py. We will write our socket server code inside this file. So let me get into the file using vim I for insert. Okay, because we need the socket module, the first thing to do is, as always, import the module. So import socket. Now the first step is to create a socket object. We will use this object across our small server program. For this, we can use the socket method and pass two arguments to this method. Let me write this first. So let's call our object srv equals socket This is the module name, dot socket. This is the method. And in between parentheses, let's use socket dot af underscore inet, comma, the second argument, socket dot sock stream. In this line of code, af underscore inet refers to the address family IPv4, and sockstream means connection-oriented protocol, so TCP. So basically we are creating an IPv4 TCP socket. Okay, that's it. Now we have a socket object. Now the next thing to do is find out the IP address of our server. Remember, we need a pair made of the IP address and the port number. To get the IP address of the machine, you can use the following method from the socket module. Also, we should store that address using a variable. So let's call it srv underscore IP equals socket dot get host by name, and in between parentheses socket dot get host name. Okay, that should do it. Now let's also define the port. Let's use a custom number, for example srv underscore port equals, let's say, 11111. Okay. The next thing to do is bind those two together, the IP address and the port number, using the bind method on the socket object. So let's use srv.bind, and in between parentheses, actually two pair of parentheses, let's use srv IP and srv port. Okay. As you can see, the argument passed to this method is actually a tuple consisting of the server IP address and server port number. Good. Finally, after binding these values together, we should tell the server to listen for connections from potential clients. For this, we have the listen method from the socket module. So this method should also be applied on the socket object we created at the beginning of the lecture. So simply write srv.listen, and let me write 2 in between parentheses. This argument 2 is called the backlog argument. The backlog argument specifies the maximum number of queued connections and should be at least 0. Okay, this was the part about configuring the server. Next, we should prepare the server for accepting connections from clients. This can be achieved using the accept method. When applied on the socket object, the returned value of the accept method is a pair, a tuple. Let's write it. So object and address, where object is a new socket object used to send and receive data on the connection, and address is the IP address bound to the socket on the other end of the connection, so the client's address. Let's write this down. So let me delete this. Client, this is the new object I was talking about, used to exchange data on the connection, comma, IP equals srv.accept. Now we can use this newly created socket object to send information to the client using a new socket method called simply send. So let's say now client.send, and let's send a message, hi, welcome, to this server. This string will be sent to a client connecting to the server as a welcome message. Finally, always remember to close the socket after performing the desired operations. This is easily done with the close method applied on the new socket object. So let's just write client.close. And that's it. Now we have a basic server socket. In the next lecture, we are going to create a client socket and make the connection to our server. Also, don't forget to check out the links attached to this lecture for further reading about the socket module.